All right, we have activity 3.2, classifying numbers. There are many ways you can classify numbers. As you saw in the previous activity, many of the classifications are subsets of other classifications. The diagram shows the different sets of numbers you have encountered in your mathematical experiences. Natural numbers are a subset of whole numbers. Whole numbers are a subset of integers. Integers are a subset of rational numbers. So basically, if I have a natural number, it's also a whole number, it's also an integer, it's also a rational number. If I have a whole number, it's not a natural number, but if it's just a whole number, it's not a natural number, but it is an integer and it is a rational number. If I have something that is just an integer, it's not a whole number, it's not a natural number, but it is a rational number. Okay? So let's see if we can go through this here. We don't need to worry about this because we're not in class and I can't think of how to do that. For each value, check all of the number sets to which it belongs. Okay? A natural number is like a counting number, so 3 is a natural number. It's a whole number because it's not a decimal. It is an integer because it is on the number line there, and then therefore it can be written as a fraction, so it's a rational number. 3.22222222, that is not a natural number because it is not like 1, 2, 3, 4. It's not a whole number because it's not 0, 1, 2, 3, 4. It's not an integer because it's not negative 1, 0, 1, 2, 3, 4. It is a rational number, though, because it can be written as a fraction. Okay. In fact, it would be 3 and 2 over 11. 0 is not a natural number because it's not 1, 2, 3, 4, but it is a whole number because it's 0, 1, 2, 3, 4. And it is an integer because it is in the positive and negative numbers, and it can be and it is a rational number because it can be written as a fraction. Okay. Negative 4.5 is not a natural number, not 1, 2, 3, 4, 5. So natural numbers are starting at 1, and then they're the counting numbers, they often say. A whole number starts at 0, and then it's 1, 2, 3, and so that's not negative 4.5. An integer can be a negative whole number or 0 or a positive whole number, and so this is not that, but it is a rational number because it is it's a decimal, it's a negative decimal, and it can be written as a fraction. Same with negative 3/5. It is not a whole number. It's not a natural number. It's not a whole number. It's not an integer, but it is a rational number. 54, however, would be a natural number. If I started counting at 1, 54 would be on my list. If I started counting at 0, it would be on my list. If I counted all the negative numbers and all the positive whole numbers, it would be on my list, and then it's also a rational number. Notice the first time it gets an X, all the ones after it are X's. Negative 5 is not a natural number because it is negative. It is not a whole number because that starts at 0. It is an integer because it's negative 5, negative 4, negative 3, negative 2, negative 1, and then therefore it is a rational number. 23 over 3 is not a natural number. It is not a whole number. It's not an integer. It is a rational number. 667 thousandths is not a natural number, not a whole number, not an integer. It is a rational number. Negative 1,364,698. It's not a natural number because that starts at 1. It's not a whole number because that starts at 0. It is an integer because it would be on my list of all negative and positive numbers that are not decimals, and then therefore it is a rational number. Okay? So can be written Okay, natural number starts at 1, it's the counting numbers. Whole numbers start at 0, and then it's all the counting numbers. Integer is like all the negatives and positives, but no decimals or fractions. And then a rational number is anything that could be written as a fraction. So again, if I had to kind of go through this again, the natural numbers, it's like 1, 2, 3. Sometimes we call them counting numbers. Okay. Then the whole numbers starts at 0. So it's 0, 1, 2, 3. And then the ellipsis means it keeps on going forever and ever. And so those are the natural numbers and 0. Integers are all the whole numbers and their opposites. I like how that's worded because they're kind of saying, hey, 3 and its opposite of -3, 2 and its opposite of -2, 1 and its opposite of -1, and 0 has no opposite. So that's how it kind of works there. Okay. And then rational numbers, I'll just give you some examples like 1/2, 35 hundredths, 5, -1/2. And so rational numbers are just numbers that can be written as a fraction. So A over B, where A and B are integers and B cannot be 0, because I cannot write a fraction with 0 as the denominator. It's impossible. Okay, and so that's the formal definition. Rational numbers are numbers that can be written as A over B, where A and B are integers and B does not equal 0. And so basically the rational numbers include all of your fractions, all of your decimals, all of your positive and negative numbers, and 0. And so it includes just about everything we've worked on in math to this point. And that is activity 3.2.